Hi guys, in this video, we are going to continue now with some other results that we get from the classical theorem. Remember, I said I call it the classical theorem because of the many nice, cool stuff that come from it. What does this theorem say? We did this as, I believe, theorem number 2. And we said this theorem says that the angle at the center is twice angle at circumference. That's what we said, right? Now, let us see what are the other results that come from this, okay? So I've got an angle at the center here, and let me measure this angle, angle BOC, sorry, 68.65, if I may just bring it closer here. There it is. And if I may measure the next angle, now I'm going to measure angle A. Angle A, we expect it to be half of this angle. So let's measure that. And here we go, 34.32. That is quite reasonable. You can go for this and check 34.32 times 2. You will definitely you'll get something like a 68.64, which is a good number that we are definitely expecting. Then finally, this one there, we can see it's 34.32. Now, let's check some interesting things here. This angle is twice that angle. Why? Because it is at the center. Now remember, we must look at the arc. The arc is this one here, is arc BC. Okay, we also have chord BC. There's a chord BC. This one is arc BC. Okay, now this one here, we know it's a minor segment. Minor segment. Segment is just a division of a circle, a part of a circle that is actually separated by a chord. And this side here, we've got from this side to there, we've got the major segment. Okay. Now, here's the interesting thing. We see that now, okay, all these angles actually, angle A, angle D, and angle BOC are actually subtended by the same arc or the same chord, if you like. We notice that angle A is equal to angle D. And we see why, because they are both angle or the circumference in relation to the angle here at the center. However, there is a result that we can then conclude out of this, because this will always be the case. We actually have a name for these angles. We have a name for angle A and angle D. When angles are in this type of position, we say they are angles in the same segment. That's what we call them. We say they are angles in the same segment. So in other words, they are equal. But another way to look at it is they are subtended by the same chord, or they are subtended by the same arc. So whenever angles are subtended by the same arc or the same chord, they must be equal. In other words, that's what we are establishing here. Okay. However, most importantly, the concept is that of the segment. Okay. So I hope you get to internalize this and you get to practice it as well. I am going to actually pause this video now and just record another part where I will talk about angles in opposite segments. Then we have a nice conclusion. All right. So guys, I want you to see actually the different cases of angles in the same segment. So what I'm going to do, I'm going to take this angle down here, angle D. You can see it still has the same size, and I'm going to take it there. You can see again, it's still, the angles are maintaining their sizes. So this is another way to see angles in the same segment. Check, look at this. I can do this. You must still be able to recognize that these are angles in the same segment. So let's play around actually and see how can we determine angles in the same segment. Look at that. Look at that. Again, they are still in the same segment. And you will realize actually, if you were to go through all past papers, that you are having, if where angles in the same segment appear, you are having different cases of what I'm showing you here. Look at this. Look at this. Look at that. Angles in the same segment. Look at that. Look at that. Just look at this. Here, there they are, right next to each other. Or one can be so far. Sometimes what the examiner does to try and confuse you or make you not see it, he puts one angle very far from another. Look at that. But now you need to be able to decipher this, to decode this, so to say. Look at this. What is happening here is you've got actually quite a number of things. I love geometry. Look at this. You've got now angles in the same segment, but at the same time, you've got, remember, diameter subtends 90. We have a case now here because this chord has become a diameter. But at the same time, look at the beauty of geometry, guys. I don't know if you getting the feeling that I'm also getting. I'm excited. I'm excited. So check this. So you see, we can actually find this angle right now. We can find this angle. We can determine the value of that angle. And subsequently, if we know the value of this angle, in fact, we can even find the value of that angle without this angle, even if we did not have that angle. How would we do that? Well, we know that we have the angle at the center. So these are radii. These are radii. So this is actually isosceles. So this angle, whatever this angle is, it must be equal to that one there. Okay, so I hope you guys are making sense of this. Okay, so I just thought I should throw that in, show you the different cases in which they can do this. They can adjust. Basically what the examiner does when he's bored or so, he will just adjust the stuff. Okay, so let's quickly now look, as I wrap up, at angles in the opposite segment. Let's look at this. Look at this now. All right. So let's continue this in another video, right?